A new heatwave is building over a country that never actually recovered from the last one. More than half of England and the whole of Wales are currently under official drought status. And now, before that drought has even had a chance to ease, another significant heat spell is arriving on top of it. But the part of this story that's actually caught scientists off guard isn't the temperature forecast, it's what satellite imagery has revealed about just how far this drought has already progressed. Comparisons so stark that researchers are calling them one of the clearest visual demonstrations yet of what a compounding climate crisis actually looks like from orbit. If you stay with me to the end, you'll understand exactly what those satellite images show, why this keeps happening to the same country year after year, and I'll give you the one number worth watching that tells you whether this drought is stabilizing or getting meaningfully worse. If you find yourself hooked by the way space-based data reveals things ground-level weather reports simply can't, subscribe right now, because this is the kind of story that keeps developing, and you'll want to be here for the next update. Let's start with what's actually happening on the ground, because the sequencing here is the whole story. This isn't Britain's first drought in recent memory. It's the third in 5 years, following major drought declarations in 2022, 2025, and now 2026. A pattern researchers describe as worryingly frequent for a country whose entire agricultural and water infrastructure was built around a historically wetter, more temperate climate. This year's version began building through the spring as large stretches of the country from April through July received significantly below average rainfall, layered underneath a series of successive heat waves. By the time satellite analysis from BBC Verify examined the data in late July, the imagery showed a landscape transformed. Vast stretches of England shifting from the lush green typically associated with the British countryside into extended patches of brown, stressed vegetation, visible clearly enough from orbit that the transformation needed no further explanation. Rivers have dropped to exposed, cracked beds. Reservoirs have receded far enough to expose infrastructure and shoreline that's normally submerged. Hosepipe bans are now in effect across large parts of the country, and water companies are warning of deeper restrictions if the pattern continues. And now, into all of that, a fresh heat wave is arriving, with temperatures forecast to climb into the mid-30s Celsius across the south and east of the country this week. Now, here's the first twist, and it's an important one. If you only paid attention to this week's heat forecast in isolation, you'd treat it the way most people treat any hot week, uncomfortable, newsworthy for a few days, and then forgotten once temperatures ease back down. That framing completely misses what actually makes this moment dangerous. A heat wave landing on ground that's already saturated with moisture behaves very differently from a heat wave landing on ground that's already bone dry from months of accumulated deficit. The second kind doesn't just feel hotter, it actively worsens the underlying drought in a way that compounds faster than either factor would on its own. And that compounding effect is exactly what satellite scientists say they're now watching unfold in near real time across England and Wales. So let's clear up a concept you're going to hear a lot in coverage of events like this, because it explains why scientists reach for satellite data instead of just reading a rain gauge. Vegetation stress. It is not simply a fancy way of saying plants look a bit wilted. Researchers measure it using satellite instruments that detect the specific wavelengths of light reflected by healthy, water-rich chlorophyll versus the wavelengths reflected by vegetation that's shutting down photosynthesis to conserve what little moisture it has left. Healthy grass and crops reflect light in a very particular signature. Stressed browning vegetation reflects it differently, and that difference is precise enough that satellites like the European Union's Copernicus Sentinel-2 can map the transition across an entire country, field by field, with a level of consistency and coverage that ground-based weather stations, scattered unevenly across the landscape, simply cannot match. When BBC Verify's analysis showed large parts of Britain shifting, color across the growing season from April into July, that wasn't an approximation. It was a direct physical measurement of plants losing the water they need, recorded from roughly 800 kilometers above the Earth's surface. So let me ask you something before we go deeper, and I genuinely want your answer in the comments. When you hear drought, does a technical measurement like satellite-detected vegetation stress feel more convincing to you than a simple rainfall statistic? Or does a number on a rain gauge already tell you everything you need to know? Drop a comment, because I think the honest answer says a lot about how differently people respond to data depending on how it's presented. Here's the mechanism that's actually driving this compounding effect. And it's not unique to Britain. Across the wider European continent this summer, the same underlying pattern has been playing out at an even more extreme scale. The Rhine and the Danube, two of Europe's most economically vital rivers, have both dropped to record or near record lows. low enough that sunken World War II-era ships have resurfaced on the Danube's exposed riverbed, and low enough that comparisons between satellite images from 2023, a roughly average year for river flow, and this August show a difference dramatic enough to be immediately obvious without any technical explanation needed. A hydrologist tracking the Rhine attributed the collapse to a combination of low winter snowfall in the Alps, months of below-average rainfall, and 5 distinct heat waves hitting the river's drainage basin this year alone. The mechanism is straightforward once you see it laid out. Hotter air pulls more moisture out of soil and vegetation through evaporation, which means the same rainfall deficit produces a more severe drought in a warmer climate than it would have decades ago. Ago and a fresh heat wave landing on already parched ground accelerates that moisture loss further still, right at the moment the landscape has the least reserve left to lose. Now, here's what makes this more useful than the doom scroll framing that tends to follow any drought story. There's a specific published scientific attribution behind exactly how much of this severity is attributable to a warming climate versus ordinary natural variability, and understanding that number tells you a great deal about what to actually expect going forward. We'll get there because it's both more precise and more grounded than treating every hot, dry summer as an unexplainable anomaly. But first, let's be honest about the genuine complexity researchers themselves flag when analyzing an event like this. World Weather Attribution, the international research consortium that specializes in rapid assessments of extreme weather, published a detailed analysis of this exact European drought event, and their own report is refreshingly candid about a technical hiccup in their process, an error in an early plotting routine for their drought severity maps that had to be corrected and republished, with the researchers explicitly noting that the correction affected only the visual representation and not any of their underlying conclusions. That kind of transparency matters, because it's a reminder that even sophisticated climate science involves real technical work that occasionally needs fixing in public. And the researchers' willingness to flag their own correction openly is exactly the kind of scientific honesty that deserves more attention than it usually gets. They're broader. Finding that this drought represents a compound crisis driven jointly by prolonged precipitation deficits and extreme heat, with the two factors reinforcing each other rather than acting independently, is the core, carefully checked conclusion that survived that correction intact. Now here's something that reframes this whole event and helps explain why researchers describe this as part of a genuine trend rather than a single bad summer. A separate scientific analysis of Europe's severe 2022 drought, the one described at the time by a senior European Commission researcher as potentially the worst in 500 years, found that while the immediate cause was a straightforward lack of rainfall, human-caused warming was responsible for more than 30% of the drought's overall intensity and mechanism of enhanced evaporation pulling extra moisture out of already stressed soil. That finding, quantified and peer-reviewed rather than estimated after the fact, gives researchers a real tested baseline for how much of an event like the current one is being amplified by warming rather than simply reflecting an unlucky roll of the dice on rainfall. And with England now having declared major droughts in 2022, 2025, and 2026, all three occurring within a 5-year window, that 30% amplification factor isn't describing a one-off event. It's describing a mechanism that's actively loaded into every subsequent dry spell the country experiences, which brings us to the assumption that tends to circulate whenever a drought story like this gets attention, the one that treats every hot, dry summer in Europe as proof that the region is simply becoming a permanent desert on an inevitable one-way path with no recovery in sight. The data doesn't support that framing, and the reasons are specific. Drought severity in any given year still depends heavily on the specific alignment of that year's rainfall patterns, which remain genuinely variable from one year to the next, even as the underlying warming trend continues. Wetter. Years absolutely still occur, and when they do, rivers recover, reservoirs refill, and vegetation greens back up. Exactly the kind of natural variability that gave Britain a relatively wet start to earlier parts of the same year before the pattern shifted. What's changing isn't that recovery has become impossible. It's that the droughts landing on top of a warmer baseline, climate now tend to be more intense and more damaging than an identical rainfall deficit would have produced several decades ago, which is precisely the mechanism the 30% attribution figure captures. So here's what actually matters going forward, and this is the payoff I promised you at the start. The number to watch isn't this week's peak heatwave temperature in isolation. It's soil moisture recovery, specifically whether autumn and winter rainfall over the coming months manages to fully replenish the moisture deficit that's built up across this growing season, or whether the country heads into next spring already starting from a depleted baseline. Britain has now done that 3 times in 5 years. If Autumn rainfall this year fails to fully reset that baseline before the next growing season begins. That's the signal that would suggest the country isn't simply cycling through independent, unrelated dry years, but is instead sliding into a pattern where each drought compounds on top of incomplete recovery from the last one. Watch the winter rainfall totals, not just this week's thermometer. There's something almost reassuring in understanding this, isn't there? Not the false comfort of assuming a dry summer is simply ordinary British weather with nothing more to it, and not the manufactured panic of assuming the country is turning to desert overnight, but the real, grounded science of researchers pointing a satellite at the ground, measuring exactly how stressed the vegetation has become, tracing precisely how much of that stress traces back to a warming climate, and being honest in public even about their own technical corrections along the way. The heat wave returning to Britain this week isn't landing on a blank slate. It's landing on ground that satellites can already see as running on empty, and that combination, more than either factor alone, is exactly why researchers are watching this moment so closely. If this made the view from orbit feel a little more understandable and a little less like an abstract, distant statistic, do me a favor and hit that like button, because it genuinely helps this kind of careful, no-hype science reach more people. Subscribe so you're here for the next satellite update, because with the drought and the heat both still active, this story is far from finished. And tell me down in the comments, do you want me to keep tracking how this drought develops through the rest of the season? I read every single one, and your questions often shape the next video. I'll see you in the next one.